It was back in 2011 that I attended my first UKNOF, and we cuddled together in a barn. There were like 5 people, and look at you guys now, the brightest and smartest of the kingdom together. And today I'd like to pick your brain regarding an idea that has been floating inside NTT's routing security team. Actually, there are 2 things I want to talk about: golden prefixes and a concept called IRR lockdown. Golden prefixes is in a, let's call it a research phase, feasibility research, and IRR lockdown is something we are pretty much committing to doing. My agenda for today is explaining why the current IRR setup is not ideal, what golden prefixes is, what it means, and what IRR lockdown means. Current frustrations are that we see hijacks. Most of them are not with malicious intent. Nevertheless, they have global impact. A famous example is the YouTube incident where people thought, let's get the website blocked, and they leaked a more specific, and then that country was taken offline entirely by the flood of traffic coming in. People managed to take full BGP tables into their OSPF process, export it through ISAS, and then dump it out with a reset AS path to the far side. And there are BGP optimizers these days, like Noction, and Internet has a product. That's all fine, but they rely heavily on the well-functioning of no export. And even in 2014, there are still bugs in, say, Cisco or Juniper, where no export apparently means do export, and you leak more specifics inadvertently, which you should not be leaking. Then a crash course IRR. IRR, in essence, is you create a small text snippet that shows your route announcement intentions, and then you upload that to a database, and other people can then query that database to retrieve a list of prefixes you might or might not announce. But the current IRR system, as it stands today, is a little bit broken. There are well-used, very big databases like RDB and Erin, where every breathing idiot that pays a little bit of money per year can insert any route object they want for any prefix. This includes your prefixes. There are, however, a few exceptions like AfriNIC, APNIC, and RIPE, who do have a solid validation chain, so you can be certain that the route object was created with permission of the actual IP owner. But even with those guarantees in place, there is still data in the system. There is no incentive for people to clean up data because their services keep working. There's only incentive for people to create route objects, but not to clean them up. RPKI could, in theory, solve some of these, but from a practical point of view, I'm not yet convinced we should deploy it. There are legal issues in obtaining the required cryptographic materials. I'm not fond of adding new protocols to the network on the scale that NTT operates. I've seen some bugs in some vendors where I'm like, we might not want to do that in production yet. So now up to the solutions. Golden prefixes. The one-sentence summary of golden prefixes is that it's a sort of SSL pinning, but for BGP prefixes. If a network tells me somehow that you should only see this /20 with this origin AS in the routing table and nothing bigger or smaller, then why, as NTT being, should I not honor that request and just reject smaller prefixes or prefixes coming from different origins? This is regardless of whether you are a peer or customer. This applies to anybody. The golden prefixes system would be a repository where you put into flat text files the prefixes that belong to an autonomous system number. We layer it with some GPG crypto so you can actually authenticate whether the information that was put into the system was put in by the actual people that manage that autonomous system, and that it was not tampered with by the intermediate party, which could be NLNOG. If we look at a concrete example, I could take YouTube's prefixes, put it in a prefix set, this is iOS XR config, and just on any BGP session in the network, drop prefixes which are matching that prefix set that YouTube gave me, but for instance, the origin AS is different. And these BGP policies can be applied to both customer sessions and peering sessions because through an out-of-band mechanism, the golden prefixes repository, YouTube signaled me this is what we want to see in the global routing table. I understand that this is competing with existing technologies in this area, but there are a few small differences. The legal surroundings of the golden prefixes repository could be licensed in a more friendly way to reduce the hurdles that some companies might have to take to accept the data. It relies on proven technology. People have been using route maps and route policies for the last 20 years or so. So adding a few extra prefix lists to your routers is, for some companies, more feasible than adding a new protocol. And of course, you locally decide which parts of the golden prefixes repository you find of interest. It might be that you have, say, 90% of your traffic to a few ASNs and that you're only interested in really protecting that majority of your traffic, and for the rest of the traffic, just go with the flow. That's up to you. Golden prefixes, to get stuff admitted to this repository, and this is still up in the air how this process should look. We could have a trusted introducer concept where you call each other, that you affirm that this guy works for NTT, that guy works for a large content provider. There would be a role of an auditor in the middle that does that follows the procedures and admits people to the repository or not. That's not something I want to spend my time on personally. And we could do checks like, has this prefix been in the BGP tables for at least a few months? If it's, you know, a prefix that has only been into the table yesterday, then it should not probably belong in the golden prefixes repository. If you would use a concept like golden prefixes, you just do a git clone of the golden prefixes repository, you run your GPG-based validator tools to check the integrity, you generate policy snippets that should be uploaded to routers. We will help you with that. I plan on writing some scripts to assist in that aspect. And then you push it out to your network devices. You can run something like this from crontab and just do it every 24 hours. So current status, we're assessing whether the community would like companies to have something like this. I mean, this process beats emailing me and asking me, hey Joe, can you maybe filter out this stuff? I want something that is like a general purpose repository where people from various companies can easily input it and multiple companies can consume that data and do something with it locally. So please ping me on Twitter or email if you have interest in this topic. Now comes another thing, and I think I have 4 minutes, so this is going to be tough. IRR lockdown. It's a novel concept. I don't think this has been done before. In essence, it means that we would only honor route objects if they come from the registry which actually manages the space. And that we would ignore all route objects that don't come from that particular registry that we lock down. Knowing that RIPE administrates 35/8, give or take, we would only allow route objects that come from the RIPE whois server directly. And this means ignoring route objects that cover RIPE space if they come from, for instance, RADB. Or ignoring route objects that customers created in our own registry, but we refer them to, please, if your space is RIPE managed, create the route object in the RIPE registry. Because as I mentioned earlier, anybody can create any route object in RADB, and I don't think we should honor those random route objects. I've noticed people register route objects and they get them admitted into the prefix filters of their upstreams, and then they start spamming the bejeebus out of it for 8 hours straight, and then withdraw the prefix again and never use it again. I want to protect RIPE managed space a little bit more than we do today. Can we pull this off? I ran some statistics and I saw that there are roughly 1,000 prefixes where the route object is in the entirely wrong registry and there is no duplicate that resembles a less specific route in the RIPE registry. So out of the 580,000 routes that we have in the DFC today, this is not that bad. The number of networks that are involved with route objects in the entirely wrong registry is quite low also. So I'm just going to call everybody and ask them kindly to put the route object in the appropriate registry. I will provide some tooling where people can check it easily and then see what happens. This is a concrete example. On the top you see that 193/8 has been handed down by IANA to RIPE NCC. And RIPE NCC's job is to distribute this space to its members. On the left side we see the proper route object, which RIPE NCC, which is for RIPE NCC's office, and they created this to be originated from AS333. Now on the right side, this route object, anybody can create that, and it will be accepted by transit providers today, is a bad object. But the big difference is in the lowest line, the left one has as source RIPE, and I can trust that RIPE properly does authentication. And on the right side, it's a non-RIPE source. So why would I honor this bad route object? David.
Hi, David Friedman, Clarinet. What are you going to do where you need to create a root object and the origin isn't a RIPE ASN? You're encouraging the creation of foreign ASN in the RIPE IRR?
Currently, there is no other way than creating a duplicate ODNAM object in the RIPE database. That part has, say, weak authentication. However, you also require authentication from the INetNum owner, and that part is a strong guarantee. So I admit that it's kind of a shitty hack, but it still gives me sufficient guarantees compared to the garbage data that we take in today. And then in the RIPE routing working group, there has been interest in developing a cross-registry authentication mechanism. So I expect that this particular corner case will slowly go away over time.
Okay, thank you.
Marco.
Yeah, it's Marco, RIPE NCC. Thanks. Two questions. One is on your 270 or so prefixes that you named, can you give an estimate on how much damage there actually is coming from those 270 prefixes? And secondly is, are there any particular IRRs that are worse than others when it comes to sending duplicate route objects?
Regarding your second question, I invite you to click the link at the bottom of my slides. It contains a full report on where RIPE NCC space has been registered with route objects, and it covers all the registries that NTT mirrors. And regarding the damage, out of the 1,000 prefixes that we see in the DFC, roughly half of them fall within NTT's customer cone. So already 500 of those are not really my problem anyway. Half of those remaining 500 belong to a single entity in the Middle East. So I've called them like please, can you stop registering stuff in RDB and move it to RIPE, and then, you know, it will save you $100 per year even. So if they resolve that aspect, then that number is down to 250, and that's an extremely manageable number from NTT's perspective, because if I don't get it cleaned up within 10 months, I would just hard code those as an exception. So I think the damage will be negligible.
Okay, any other questions for Joe? Okay, thank you very much.
Thank you.